right, let's look at a few problems here on page 316. We'll start with number 14. They give you this parallelogram here. They give you some information. P to T is 2x, TR is y plus 4, and so forth. You do need to realize that the diagonals bisect each other. So QT is equal to TS, and TR is equal to PT. So when we look at this, PT is this yellow line, and it should be equal to TR, this yellow line. So we're going to make those two parts equal. QT here in orange will be equal to TS here in orange. And then once we do that, we're going to solve for the systems of equations. So yellow is equal to yellow. So 2x is equal to y plus 4. That's one equation. You have two variables there, so you need a second equation. And we're going to say orange is equal to orange. X plus 2 is equal to y. And now you solve these systems of equation. You'll notice right here y is by itself, which is great. So I'm going to take this information, x plus 2, and plug it right into the other equation where I see a y. So this is just basic algebra here, and you don't want to make a dumb mistake. And it looks like the answer for x is 6. And then you would just take that number and then plug it in here. This is 6 plus 2, and then y would be 8. X is 6, y is 8. But the key is the fact that the diagonals bisect each other. We're going to tackle number 41 here. It's a little word problem. It says, in a parallelogram, one angle is 9 times the size of another. Find the measure of the angles. First of all, it's a parallelogram. So, even though I'm just sketching a parallelogram, A, B, C, and D, one of the angles is 9 times bigger than the other. And really, even though you see 4 angles, there's only 2 actual different ones. Because A is the same as C and D is the same as B. So if this one looks small, so this one will be X, and this is not the one that's 9 times bigger than that. This would actually be X. The one that's going to be 9 times bigger than that would be this obtuse one. This would be 9X, and this is 9X. Now, we have a setup here. Now, we can't just say 9X is equal to 9X and go opposite angles are equal. There's nothing to solve here. Can't really just say X is equal to X. But what we can do in a parallelogram is consecutive angles. This angle A here and this angle B are not equal, but they are supplementary. And that's what we're going to do. We're going to say 9x plus the other angle x is equal to 180. This is 10x. It looks like one angle is 18 degrees, and the other is 18 times 9, and that would be 162 degrees. And those are the two different angles there. Okay, but you've got to realize it starts as a word problem, but it's really, if you draw the picture, you can come up with an equation from that word problem. All right, we're going to take on one of the two column proofs here. It says given, this means parallelogram LENS and parallelogram NGTH. Our job is to prove why this angle L is equal to this angle T here. Okay, so we'll obviously start with the given. So parallelogram LENS and parallelogram NGTH. That's given. Now, because you have parallelograms, there are a lot of different properties. I'm looking back in our notes here. Parallelograms, opposite sides are parallel. That's the definition of a parallelogram, when you have opposite sides parallel. But also, opposite sides are congruent. Opposite angles are congruent. The diagonals bisect each other. Consecutive angles of a parallelogram are supplementary. So it's literally potentially 5 different things that can occur given the fact that you have parallelograms. Well, we're trying to prove why 2 angles are equal, so we're not going to be concerned about the sides. We're going to talk about the angles. And so what we're going to do here is step 2. Let's go with angle L is congruent to angle N. So I'm going to say this angle here is equal to this one. I'm also going to mention that angle T is equal to angle, well, actually, I shouldn't say N here because I really need to say angle ENS. ENS. There's just too many angles right there by N. And then I'm going to also say angle T here is equal to angle GNH. GNH. And the reason is, don't go with definition of a parallelogram. Because the definition of a parallelogram just means things are parallel. But what we want to say is, in a parallelogram, because we do have parallelograms here, opposite angles are congruent. We're just going to spell it out. Okay. Opposite angles of a parallelogram are congruent. Okay. Again, some of you might feel like, oh, I'll just write definition of a parallelogram. Definition of parallelogram is technically just parallel sides, but we want to mention that opposite angles are congruent. All right, so I got a tick mark, a tick mark, a tick mark, a tick mark. Eventually, though, we want to figure out why this yellow angle L is equal to the angle T here. We haven't said that yet. Let's go with this. Let's say that these two are equal to each other because they are vertical angles. So what I'm going to eventually do is this equal to this equal to this, and then this equal to this. And all four of these angles will be equal to each other. But let's go with these vertical angles here. ENS is equal to angle GNH because those are vertical angles. And now we can kind of go, and it would be a lot of different scenarios. It might be like two substitutions in a row, but we can now basically say angle L is equal to angle T, because I've got this angle equal to this because opposite sides of a parallelogram are equal. Then I can substitute with that, which is a vertical angle, and those are equal because those are opposite sides of a parallelogram are equal. So now the far extreme angles are equal, and we'll go with substitution. You're doing actually kind of two substitutions here, but we are going to substitute. Basically, you have a lot of different parts that are equal within these three things here. You're equal to this, and these are equal to that, and then eventually you can get down to L is equal to T. Substitution. And finally, we'll fill out number 43, another two-column proof here. You've got two parallelograms, and you want to figure out why LS is parallel to GT. So why the bottom line is parallel to the top line. So we'll go with the given, of course, LENS, and parallelogram GNTH. That's given. We want to talk about things that are parallel, so that's what we're going to do. We'll go LS, this bottom line, is parallel to this middle line, which we'll say EH. And I will also say the top line, GT, is parallel to that same middle line, EH. And this is because we've got parallelograms, opposite sides are parallel. This one you can actually say definition of a parallelogram. Or if you don't, not quite sure, because there's so many different properties of a parallelogram, you can say in a parallelogram opposite sides are equal. Opposite sides are parallel. Okay. Now we've got the LS parallel to the middle, E to H. GT at the top parallel to the middle, EH. Seems to reason that the bottom would be parallel to the top, almost by substitution, but it's not quite substitution, because substitution implies equal signs. But we're just going to spell out what we're thinking here. The bottom line, LS, is parallel to GT, and instead of saying substitution, we're going to say if two lines, and those lines are LS, the bottom, and GT, the top. If two lines are parallel to the same line, which is the middle line, EH, then they are parallel to each other. Now this could have been a substitution if these were all equal signs. But because it's not an equal sign and they have parallel signs, we're just going to spell out what we're thinking. The bottom and the top are parallel to the middle, EH, therefore they are parallel to each other.